Here we're going to review switched port analyzer or SPAN technology. SPAN will help you troubleshoot your switched network. And what SPAN does is takes traffic on a particular source, whatever you specify, and copies that traffic over to a destination. And generally on that destination then you have some sort of a network analyzer or sniffer so that you can review that traffic, and you can review it without causing an issue to the flow through the source, right? Because it just takes a copy and sends it onto the destination, or sets it onto the destination. So we have a couple options with SPAN. So we'll look at SPAN, right? Let me change this. All right. Within SPAN we have local and remote. Local SPAN, Local SPAN, we have local and remote. Local SPAN means the source and the destination are both on the same switch, and remote means that the source and the destination are on different switches. Okay, here we're going to do local. So we will configure, what we're going to do is we're going to configure FA02, so let's pretend that we have some sort of an issue with traffic flowing through here. So we're going to configure FA02 as our source, and all the traffic coming through FA02 will be copied over to FA01 so that our analyzer can analyze it, so that we can see it go through the analyzer and we can actually look at it and try to figure out what's happening there. Okay? So the first thing we're going to want to do then is verify that we have connectivity in our simple network. It's a simple network. They're all on the same VLAN, all on the same switch. So we should be able to ping. But the other thing I want you to notice when we ping, and then I'll show you, is that our capture is only showing, right now we're using Wireshark as our sniffer, so the only thing Wireshark's going to show us is broadcast and multicast traffic, because by default, right, switch action, once it knows where to send the traffic, it has it in its MAC address table, it automatically sends it to the destination. So that means that all the other interfaces on the switch, the only thing they're going to see, if it's not destined for them, is broadcast and multicast traffic, which is all it sees right now. So if I bring up, what I'm going to do is I'm going to, just to test connectivity, I'm sitting on our sniffer machine, and I'm going to go through and I will ping .1 and ping .12. And so before we begin, I want to verify that we have connectivity there. I'm also going to, although you guys won't get to see it, will you? Let me think about this. No, that's okay. I won't do that. So I'll just sit here and I will just ping these two, verify we have connectivity, then we can go ahead and configure SPAN. It's only 2 commands. It's relatively easy. So let's pull that in and bring our command prompt in. Let's bring this up so you can see this a little better. If we go ahead and ping 1.12 first, good to go, and 1.1. And we're good to go. So we have connectivity. The other thing I want you to notice, though, is nothing changed here. I didn't see any of those ICMP packets within our sniffer. They would have come up here, but we did not see them because my switch already had in its MAC address table, it knew how to get to both those hosts. And so that means that it's not going to broadcast out any sort of ARP packets to find out, in this case, because it knows. So all I'm going to see then is, again, broadcast in my sniffer. However, remember my goal right now for this little section is I want to analyze that traffic going through that fast Ethernet 02. It's not as simple as just turning on my analyzer and assuming all the traffic is going to come to me. We're going to configure local SPAN to do that, to go ahead and copy those packets over. All right, so we're on our switch, and it's only 2 commands, and they both start with monitor session. Basically, I'm going to monitor session, specify the source of the traffic, monitor session, and specify the destination. Now the next step is the session number. The session number is important because remember I have the 2 commands. The way those 2 commands are linked is through the session number. So the session number is what creates the session as a whole, creates that source and destination combination. If they're different, they won't work together. Now I can have multiple sessions on the same switch, and the number of sessions is certainly dependent upon the switch platform itself, but to link the source and destination, the session numbers have to be the same. So in this case, we're going to use monitor session 1, and our source. Now let's hit a question mark so we can review what our sources can be. And again, our sources can be an interface, can be remote, which we'll deal with in the next section. We'll do remote span in the next section, or a VLAN. In this instance, we're going to make it interface fast Ethernet 02. But what I also want you to know is that an interface doesn't, in our case, our interface is an access port connected to another host, so we can just kind of show what's going on. Our interface could also be part of an Ether channel bundle if we want to monitor the traffic going over that link. It could also be an Ether channel itself, so if we wanted to monitor the traffic over an Ether channel. So if we do a source, we got interface, remote, and VLAN. We're going to do interface. And just to show you what I'm talking about, we're going to hit question mark again. This switch has fast Ethernet and gigabit interfaces, and if we had port channels configured, we could also monitor that port channel, so that could also be our source. In our case, it's going to be fast Ethernet 02 is our source. Okay. And now we want to specify our destination. We want our traffic copied over to fast Ethernet 1, right? I'm going to take our traffic from here, copy it over to 1, so that we can go ahead and analyze it. So let's go back then to our configuration. And do a monitor session. It's got to be 1. Remember, we want to link those two. Now, by default, a monitoring interface it only deals with that copied traffic or that mirrored traffic. It won't handle frames that are sent to that destination, right? So, and usually that's just fine, because all we're doing is we're using that interface to review the traffic that I think is questionable, or that I'm having an issue with. However, if you did want to, so destination interface, so let's move this out of your way. So our destination interface is FA01. So by default, this interface, once I hit enter, it'll only deal with the mirrored traffic. Any other traffic coming through that interface is just going to drop. But I can use the ingress command. So if I do a question mark, I just want to show you, if I want, for some reason, traffic to come in that interface, so if I have something on that interface that needs to get traffic, I can use the ingress command to go ahead and specify that it's okay for traffic to come through here. But by default, we wouldn't. We would have to use, by default, it only would deal with the mirrored traffic and drop all the other traffic. If we wanted it to not drop the other, or the non-mirrored traffic, we'd have to continue on with the ingress command. And we're not going to do that, but then he would set what VLAN would be for that traffic and whatnot. Anyway, so let's go back. This is what we want to do. We want to basically say, hey, monitor our source. What do I do with it? There we go. Here's our source. Take all this traffic from here and mirror it over to FA01. So let's go ahead and hit enter. Okay. Now we can also then show our monitor session with the show monitor command. I don't want to back out, so I'm going to do a do show monitor. And now I can see my monitor session. So session 1, the type of session, so it's telling us it's local span. The source port going both directions. Because I didn't specify, the default is both, transmit and receive. Fast Ethernet 02. The destination is 1. Encapsulation is native. And ingress is disabled because I never used that ingress command. So what I mean by both, and I realize now that I didn't explain it when I went through, so I'll start the command and just not finish it. Monitor session 1 source interface of A0/2. I could have done a transmit and receive. Okay. By default, if I just hit enter like I did, it will do transmit and receive, so traffic going in and out. The transmit and receive, whether you specify it, it's from the view of that source port. Does the source port see that traffic is coming in, or does it see it as going out? I could have also specified a range of interfaces. So if I had a group of interfaces that I wanted to monitor, I could use a dash if the range is consistent, at 1 to 3. and then use the comma if there's a break. So range 1-3, comma 5, FA05. So I could have done that. That wasn't in our configuration plan here, it's not in our topology, but I could have done that. And so when you saw both in our monitor session, but you never saw me type it in, that's because it is the default. And let's just get rid of this because we don't need it. Now let's go back and ping through again. And what we should see is that our sniffer saw the traffic now, that our traffic is getting passed back over. So I'm going to pause this and then go move my windows around for you. All right, so now I've got some windows. Now what I want to do is, actually you're not going to be able to see me do this because it's on this other machine that I'm not screen capturing right now. But what I'm going to do is I'm going to ping from this computer through to this one. And what should happen if we configure this correctly, which we should have, is those pings that are ICMP should then be copied over here, and my sniffer should see them. Before I do that, I want to go back, I realized again, and just show you one more thing. Let's do a show, actually let's just exit out here. Let's do show interface, FA0/1. The only thing that I want to show you is notice that it's monitoring, and right now it shows as down. It's up, we're going to see our traffic, but once it goes into monitoring mode again, just to reinforce that, unless I use the ingress command, that interface will drop all traffic that's not mirrored traffic. And you'll know that, so if you do this to yourself and you configure it, and now all of a sudden you can't figure out why you can't ping the stuff connected to it, go ahead and look at it, and if it says monitoring, you'll know why, right? All right. Back to our capture, back to our pings. Actually, I don't need the ping here, I just need my capture, right? Because I'm not pinging from this computer. So let's just go ahead and make our capture window a little bigger. Now I'm going to go over to our other host, that's 192.168.1.12, and I'm going to go ahead and I'm going to ping through to our PC2, 192.168.1.1. And we should now see, I did a continuous ping, but now we're seeing our ping traffic like we're supposed to. So that was it. Before we didn't see it when we pinged through, remember? Now we do. And that we spanned our traffic, or we are now monitoring the traffic going across to FA02. So that's it. If you have any questions or anything, let me know. I hope that helped a little bit. Next we'll look at remote span, or RSpan.